Okay, hello everyone. Today we will be learning about the curvature of the graph. Okay, so if we are given a graph of y-axis and x-axis, so this is a curvature graph. Okay, at this point, a curvature represents how fast does the graph change its direction. Okay, so K, we call it kappa, represents the curvatures of the graph. So if the kappa is higher, that means the graph is more curvy. Okay, so now we'll be looking at the formula regarding to the curvature. Okay, in this lesson, the curvature of the graph is actually not a hectic. It's not that hectic. Okay, so K kappa represents the curvatures of the graph. Okay, with a given function as usual, y equal to f bracket x. Okay, so the curvature K would equal to modulus d square y over dx square. That means the second derivative. So it's in the modulus. That means this will always be positive over bracket 1 plus dy dx square. Okay, power of 3 over 2. So if you get this formula, so that means you could get the curvature of the graph. Okay, so this we call it rho. This represents the radius of the curvatures, which is equal to 1 over kappa. Okay, so for the second one, we will be talking about the curvature of parametric curve. So for x equal to x bracket t, y equal to y bracket t. Okay, as usual, so the curvature would equal to k modulus the first derivative of x times the second derivative of y minus the first derivative of y times the second derivative of x. Okay, over bracket the first derivative of x square plus the first derivative of y square, and then the power of 3 over 2. So this is the formula to find the curvature for the parametric curve. Okay, so same as the previous one, the rho is equal to 1 over kappa to get the radius. So that's all for the curvature formula.